to another ASMR video here on the channel, and as you can tell by the title, we are back with another Fascinating Figures episode, our little ASMR history series where we take a little look at some famous people from history and recent times as well. The series knows no bounds. Now today's episode was requested, I can't remember who by, but you'll appear here. Thank you for the request, and it is of course Albert Einstein. Super interesting guy who obviously has had a massive influence on science, so we're going to take a relaxed, whispered look at his life and his achievements, so hopefully you find it relaxing and educating. And before we get into it, leave a cheeky like. Why not? It's free. But yeah, without further ado, let's get into the life of Albert Einstein. So, Albert Einstein was born on March 14th, 1879 in Ulm, Germany. He was the first child born to Hermann and Pauline, a bourgeois Jewish couple married 3 years earlier. Hermann began work as a merchant in the featherbed industry, but when his business collapsed, he moved his family to Munich to start an electrical engineering business with his brother Jacob. This venture was largely supported by the Kochs, Pauline Einstein's parents. Pauline, a talented musician, introduced her son to the piano when he was a small boy and encouraged his passion for the violin, an instrument he studied from ages 6 to 13. In 1881, Hermann and Pauline had a second child, Maria, called Maja Beil, who knew her. She was Albert's closest childhood friend. Her biography of Einstein, written in 1924, is the source of how much of the lore about Einstein's early years. For instance, Maria relates that when Einstein was born, his mother worried that his head was too large, and his grandmother exclaimed that he was much too fat. A few years later, when Einstein was 4 or 5, he had his first scientific experience. His father showed him a pocket compass, and the young boy marvelled at the fact that regardless of where the compass was turned, the needle always pointed north. Einstein thus demonstrated an interest in science and problem solving even before he entered school. Einstein's formal education began at age 6 when he enrolled in the Peterschule on Blumenstrasse, a Catholic elementary school in Munich. Since his parents were not practicing Jews, they cared more about the school's academic standards than its religious affiliation. Einstein did well in school, but he was a quiet child and kept his distance from his peers. He was uncomfortable with the principle of absolute obedience and the military drills that dominated the school's atmosphere. The young Einstein preferred to build houses of cards and play with his sister at home. At the age of 10, Einstein was accepted into the Luitpold Gymnasium in Munich, a formal and respected institution that emphasized Latin and Greek over mathematics and science. Unhappy with the educational program at school, Einstein turned to a course of personal study outside of school. His uncle Jacob lent him a book of algebra and sent him math puzzles to solve. In addition, a 21-year-old medical student named Max Talmud, a friend of Einstein's family, lent him books on popular science and philosophy that the young boy eagerly devoured. At the age of 11, Einstein went through an intense but brief religious phase in which he observed the kosher dietary laws, read the Bible avidly, and composed short hymns to the glory of God. However, midway through his preparation to become a bar mitzvah, he became disillusioned with his faith as a result of his growing scientific resent organised religion and all forms of dogmatic instruction. In 1893, Einstein's father and uncle sold their business and moved to southern Italy. They planned for the boy to remain in a boarding house in Munich to complete his education in the gymnasium before joining his family in Pavia. However, after 6 more unhappy months at school, Einstein persuaded a doctor to write him an official note diagnosing him with neurasthenic exhaustion. This provided him with an excuse for leaving school and moving to Italy. Einstein also may have been motivated by the desire to escape military conscription, since German law stipulated that if a boy left the country before the age of 17, he would be exempt from military service. Wow, Einstein, dipping out of military service. Einstein's unexpected arrival in Pavia surprised and dismayed his parents. The boy announced that he intended to renounce both his German citizenship and his Jewish faith. These renunciations testified to his isolation and independence from the world around him. However, he reassured his parents that he planned to study for the entrance examinations at the Federal Swiss Polytechnic in Zurich, an advanced technical institute. Though Einstein studied physics diligently during the summer of 1895 in preparation from the Zurich Polytechnic, he failed the necessary exams for admission. Einstein failing exams. You see, so people, if ever you're feeling bad about not doing so great in your exams and whatnot, Albert Einstein failed his exams when he was younger, so keep the faith. At the suggestion of the principal of the Polytechnic, he spent the next year in a Swiss secondary school in Aarau, preparing to retake the examination. There, he boarded in the home of Jost Winteler, a teacher at the school. Einstein got along well with the 7 Winteler children and enjoyed his year in Aarau immensely. By the time he received his diploma in 1896, he had become a confident, self-assured and increasingly communicative individual, a far cry from the quiet and lonely boy of his gymnasium days. Einstein enrolled in Zurich Polytechnic in October 1896, although he was still 6 months short of the official minimum age of 18. He participated in a 4-year teacher's training program that would qualify him as a specialised high school teacher of mathematics and physics. He lived in student lodgings in the bourgeois district of Hottingen, first in the apartment of Frau Henriette Hagi, and then had a small pension run by Stephanie Markwalder. Throughout his 4 years of study, he lived on the modest income of 100 Swiss francs per month, most of which was provided by his maternal grandparents. Einstein's decision to enroll in a teacher's training program may seem surprising in light of his own unhappiness as a schoolboy in Munich. The joy he took in learning came from his informal education at home, not from his experience in a school with formally trained instructors. However, his teaching course may have been an attempt to reach a compromise with his family, which was in financial trouble at the time. The factory run by his father and uncle had failed in 1896, and most of the family funds were lost. Thus, despite Einstein's desire to master the frontiers of physics, he also recognised the importance of securing a steady income. Einstein did not abandon physics, however, indeed studying it seriously in the laboratory of the head physics professor at the Polytechnic, Heinrich Friedrich Weber, who was best known for his contributions to electrical engineering. Yet, although Einstein admired the professor's achievements, he was distressed to learn that Weber, a staunch believer in classical physics, was hopelessly old-fashioned, dismissing of all the advancements in electricity and magnetism since Helmholtz's discoveries in the 1850s. Once again, as in high school, Einstein relied on independent study. read widely the works of Maxwell, Kirchhoff, Hertz, Helmholtz, and contemporary physicists. Einstein also benefited from his studies with his mathematics lecturer, Hermann Minkowski, who would later prove instrumental in devising a strict mathematical formalism to support Einstein's theory of relativity. In my notes, there are now some bits about his sort of like romances and his friendships. We're just going to skip over that. Not too interested in that. Let's move on with his story. So, Einstein graduated from his teacher's training program at the Zurich Polytechnic in August 1900, along with 3 other students. 2 of these students immediately obtained positions at the Polytechnic, but Einstein was not so fortunate. Professor Weber, a German, was not particularly fond of the student who had renounced his citizenship and relied on his friend's lecture notes to pass all his classes. While unable to find employment immediately after graduation, Einstein spent the summer of 1900 living with his family in Milan. Over the next 3 years, Einstein obtained temporary teaching positions while working on his doctoral dissertation on the kinetic theory of gases. His job search became less difficult following the publication of 3 papers in the prestigious Annales de Physique. These papers, along with the dissertation, reflect Einstein's frustrations with the mechanical worldview that dominated physics throughout the 19th century and into the 20th. The mechanical worldview refers to the Newtonian view of the universe, according to which all natural phenomena arise from the interactions among moving matter. This matter obeys Newton's 3 laws of motion involving action and reaction, force and acceleration, and inertia. According to Newton, all matter consists of small particles, which the English chemist John Dalton referred to as atoms in the first decade of the 19th century. The motion of atoms was set against a background of an infinitely flat absolute space and a strict linear absolute time. Over the course of the century, chemists and physicists struggled to come to terms with the existence of atoms and their properties. Einstein's early papers represent his attempt to extend the atomic mechanical perspective to several phenomena in physical chemistry. His first 2 papers, published in 1901 and 1902, deal with the nature of forces between molecules. Einstein based his calculations on the principle that these molecules obey a universal law such as gravity, though today we know that these interactions are governed by the actual size of the molecules. Although his early papers had their flaws, Einstein successfully applied the laws of statistical mechanics to atoms, thus achieving a general molecular theory of heat. In his dissertation, he developed a statistical molecular theory of liquids and showed how the laws governing the dynamics of heat flow could be understood in terms of the motions and collisions of Newtonian atoms. I realise this is a lot of science jargon and a lot of technical speak, but I think there's actually quite a lot of nice words in here, good ones for ASMR, like dynamics, thermodynamics, molecular theory, statistical, words like that. So if you are still with me or drifting off, at least we are relaxed by these words. I'm waffling. Let's get back to Einstein's story. Einstein's attempt to unify thermodynamics and mechanics demonstrates an overriding philosophical trend in his work as a whole. From the very beginning of his career, he was determined to find unifying themes in physics. This drive for unity would figure centrally in his formulation of relativity. Moreover, the context of Einstein's desire for unity was larger than the field of physics alone. A unifying spirit pervaded Central European thought at the turn of the century and shaped ideas such as German idealism, Romanticism, and Historicism. One of the most famous and influential 19th century German poets, Johann Wolfgang von Goethe, probably butchered that, for unity, wholeness, and the interconnection of all parts of nature. Einstein's drive for unity was thus not just a response to the state of physics in his day, but also the product of a broader cultural trend. Now, in spite of his early publications and his great vision, Einstein actually had difficulty finding means of supporting himself following his graduation. In early 1901, he sent dozens of postcards to eminent scientists around the continent offering to work as an assistant. Even his father wrote letters on his behalf. Well, he couldn't get a job back then. Imagine the struggle he'd have as a student now coming out of uni. Finally, in April 1901, he was offered a temporary teaching position at a technical school in Winterthur, about 20 miles from Zurich. The following year, with the aid of his college friend Conrad Habicht, Einstein found a job as a private tutor to an English boy in the small town of Schaffhausen. Soon thereafter, in 1902, Einstein resigned from his position and set off for the Swiss city of Bern in the hope of securing a job at a patent office run by a friend of Marcel Grossman's father. Unlike his peripatetic, don't know what that word means, unlike his peripatetic years as a teacher, Einstein's stay at Bern was to constitute one of the most intellectually fruitful periods of his scientific career. Strap in, folks, here we go. In June of 1902, Einstein was offered a job as a technical expert at the Bern Patent Office. For an annual salary of 3,500 francs, he was responsible for deciding whether submitted inventions were deserving of patent protection, whether they infringed on existing patents, and whether the products actually worked. Einstein could complete his tasks so quickly and so well that he had ample spare time in which to pursue his scientific work, and was even granted a raise of 400 francs soon after being hired. Go on, Albert, lad, secure that bag. While living in Bern, Einstein met regularly with a close circle of friends who shared his interests in physics and philosophy. These individuals included the Romanian student Maurice Solovin, his old friend Conrad Habicht, an electrical engineer, Lucien Chavan, and Einstein's closest friend from the Polytechnic, Michel Angelo Bezzo. These men met late into the night to discuss their intellectual interests and refer to themselves as the Olympia Academy. Bit weird coming up with a name like that for your friend group, but fair enough, you do you, mate. At the end of 1902, Einstein's father suffered a heart attack, and Einstein returned to Milan to visit him. On his deathbed, Hermann Einstein finally consented to Einstein's marriage to Mileva Maric, and the couple wed on January 6, 1903. By this point, Mileva had lost much of her interest in science and became a housewife. The couple's first son, Hans Albert, was born in May 1904. I've just realised just how much is left in these notes, so I may have to cut somehow, because otherwise this is going to be really long, and it's currently very late and I need to go to bed. So let's move on. So the years 1903, 1900 to 1905 the years 1903 to 1905 were arguably the most productive years of Einstein's career. In 1905, he published 3 papers that would transform physics in the 20th century. The subjects of these papers were Brownian motion, quantum theory, and special relativity, each of which represented a groundbreaking solution to the most pressing problems facing physicists in Einstein's day. The paper on Brownian motion, entitled On the Movement Demanded by Molecular Kinetic Theory of Particles Suspended in Liquids at Rest, tied in closely with Einstein's dissertation on the statistical molecular theory suspended in a liquid, first noticed by the English botanist Robert Brown in 1828. Einstein predicted that the random motions of molecules in a liquid impacting on larger suspended particles, such as bits of pollen, would result in irregular random motions of the particles. Irregular random motions of the particles, not fandom. What am I on about? From these particles' motion, he could then determine the dimensions of the hypothetical molecules causing the motions. This paper, published in the Annalen in 1905, brought Einstein numerous admiring letters from scientists throughout Europe and helped establish his reputation as a significant contributor to physical theory. In his 1905 paper, Einstein demonstrated that light could only be emitted or absorbed in finite discrete units. This idea challenged the standard physical theory of the time, according to which light was a continuous wave. In the 1860s and 70s, James Clerk Maxwell had shown that light is a wave of electric and magnetic fields, and that atoms absorbed or emitted light waves in a continuous fashion. However, Einstein showed that the continuous waves of Maxwell's equations could be considered only averages over all the light quanta emitted or absorbed. Einstein used his light quantum hypothesis to explain another important puzzle, the photoelectric effect. This experimental phenomenon involves the ejection of electrons from a metal irradiated by light. In the experiment, light of various frequencies is shone on the metal. Once a certain threshold frequency is reached, the metal ejects electrons in response. The energy of these electrons rises linearly with the frequency of the incident light. Gosh. You can tell science isn't my strong point. I'm reading this just like absolutely brain dead. These results could not be explained according to traditional wave theory, because according to this view, this energy of light is proportional to its intensity. So the energy transmitted to the ejected electron should be proportional to intensity rather than frequency. Einstein explained that if light is considered as composed of discrete particles, later called photons, then each photon would carry a definite amount of energy that was then imparted to the ejected electron. Moreover, the energy of an incoming photon would have to be great enough to eject an electron in the first place, resulting in a frequency threshold. Thus, Einstein was able to provide a theoretical explanation for the energy versus frequency graph of the photoelectric effect. And you know what, Einstein, I will take your word for it because I did not understand a word of what I just read, but we move on. So, Einstein's relativity theory was the product of his aesthetic discomfort with an asymmetrical explanation. Einstein was not the first to formulate a relativity theory, however. Galileo had considered the theory in the 17th century. According to Galilean relativity, the laws of mechanics are useless to an observer in a non-accelerating reference frame trying to determine whether he or she is moving with respect to another reference frame. When Newton revisited this problem 50 years later, he attempted to solve it by postulating an absolute space, eternally at rest, relative to which any reference frame was either at rest or in motion. However, the fundamental principle of relativity remained the same. The laws of mechanics are the same in all inertial reference frames, so it is impossible to determine whether an observer in one frame is moving or stationary with respect to another frame of reference. Einstein's relativity theory was presented as a principled rather than a constructive theory. A principled theory is one that begins with principles and then uses these principles to explain the phenomena. A constructive theory starts with the observations and culminates in theories that explain and reconcile these observations. Einstein's principled account began with the postulate that the laws of science should appear the same to all freely moving observers. In particular, all observers should measure the speed of light as the same regardless of how fast they are moving. Thus, there is no universal time that all clocks measure, rather everyone has his or her own personal time. If one person is moving with respect to another, their clocks will not agree. To an observer moving in one frame of reference with uniform velocity relative to a second frame of reference, the clock in the second frame will appear to move more slowly than his own clock. Moreover, since velocity is the measurement of distance per unit of time, a measuring stick in the second time frame would appear contracted to the observer in the reference frame. Of course, we do not observe these effects in everyday situations of movement. We do not see a ruler as contracted if we are moving by on a bus. Rather, these phenomena are noticeable only at speeds near the speed of light. Nonetheless, Einstein's relativity papers show that time and space are not a priori categories of human understanding. Rather, they are relative quantities that are defined operationally. This is just absolutely blowing my mind. I mean, this is slightly more technical and, academic than the Leo DiCaprio one where we just went through the films he'd acted in. But, that's what we do on the channel. We cover a variety. Now's a good time. Leave a comment who you'd like to see covered. This isn't the end. This is just a mid-video plug. But recommend someone as far away from Albert Einstein as physically possible. I am enjoying this, but at the same time, I don't understand what's going on. Help me. Now I'm looking through these notes, and it's just breaking down his relativity theory. Obviously, this Einstein's relativity theory is basically the main thing he's famous for, right? This is talking about E equals mc squared. Yeah, and wait, is this all? When did he do this? Because I'm now just scrolling forward, and it's now talking about his long foray into academic life. Surely he didn't do this before he was actually a professor. Well, let's read this part and see. Einstein's long foray into academic life began in 1908 when he was offered an apprenticeship as a private docent, maybe, at the University of Bern. Although this was merely a teaching job and not a faculty position with a fixed salary, one had to serve in this capacity before becoming appointed to a professorship. No way he's done relativity before he was a professor. That is ridiculous, unless this has jumped about, so don't take my word for it. Einstein continued working full-time at the office, and during this period of his career, Hermann Minkowski, one of his mathematics lecturers from the Zurich Polytechnic, developed a mathematical interpretation for the theory of special relativity. In July 1909, Einstein resigned from the patent office and began to work full-time as a theoretical professor at the University of Zurich. His position was that of Professor Extraordinarius, which was a step up from Privat Docent, but still not a tenured position at the top of the academic echelons. Extraordinarius professors still had to teach several hours a week and supervise PhD students. Although Einstein enjoyed these activities, he resented having to spend so much time away from his own research. Only the position of Professor Ordinarius would free him to devote himself fully to his theories. Einstein was offered such a position that same year by the University of Prague. In Prague, Einstein and Mileva enjoyed a higher standard of living, but their relationship became increasingly tense. Mileva was unhappy with the move because she felt like an outsider in a foreign land. She also felt increasingly jealous of Einstein's colleagues and friends, especially his cousin Elsa Lowenthal, with whom he was quite close. In 1910, Mileva gave birth to a second son, Eduard, who would be diagnosed with schizophrenia and eventually die in a mental institution. Wow, that's really sad. The year and a half that Einstein and Mileva spent in Prague was a very difficult time for their relationship. 1912, Einstein and Millever left Prague because Einstein was appointed Professor of Theoretical Physics at the Zurich Polytechnic, the very same institution that had once rejected him as a student. Wow, way to say, F you, look where I am now, mate. In Zurich, Einstein spent most of his time trying to determine whether the principle of relativity also applied to systems that are accelerated relative to one another. Are the laws of physics always the same for all observers, even those in non-inertial reference frames? The answer to this question, which Einstein worked on until November 1915, was the general theory of relativity. While developing this theory in Zurich, Einstein benefited from the mathematical assistance of his old friend Marcel Grossmann, who was one of the only people in Zurich with whom Einstein could discuss his new ideas. Their collaboration led to the publication of a partially successful version of the general relativity theory in 1913, followed by a more complete version in 1915. So I believe Einstein was now poached to a different uni, and Einstein moved to Berlin with Millever and their sons in April 1915. However, by this point their marriage had turned fully sour, and Millever and the children returned to Zurich in June with the helpful intervention of Einstein's friend Michel Besso. Although Einstein and Millever did not officially divorce until February 1919, Einstein knew that their 1915 parting was final. He had already begun spending large amounts of time with his cousin Elsa. When Einstein fell into a prolonged sickness in early 1917, Elsa nursed Einstein back to health. By the summer of 1917, he had moved into a flat next door to Elsa, a clear sign that it was time to begin divorce proceedings with Millever. Thus, after nearly a decade of travelling from one country to another to fill a series of increasingly prestigious academic posts, Einstein at last settled with the woman who would become his second wife and his lifelong companion in the country from which he had renounced his citizenship. So wait, he married his cousin? He married his cousin. Oh, okay. I haven't understood the vast majority of what I've been whispering to you all, but I can understand that. Fair enough, you know, whatever floats your boat, I guess. This is now breaking down why Einstein's special relativity was special, because it only dealt with specific case of inertial reference frames. I think we've had enough science talk for this episode, so we're just gonna sort of keep scrolling through and move on with his life, because I don't need to fry my brain anymore. Hopefully you found this relaxing and interesting and managed to understand some of it. I knew it was going to be quite scientific when it was requested, but you know, like I say, I think it's important to cover a variety of different figures, different topics and stuff. So it talks about space-time and stuff. I mean, obviously, if you want to look it up for yourself, knock yourselves out. But yeah, after completing the general theory of relativity, Einstein began working on a clear and comprehensive presentation of it. Until this point, most of his publications were just provisional reports on the state of his research, comprehensible only to those physicists who had been following his work all along. In 1916, he published a treatise entitled Foundations of the General Theory of Relativity, in which he established the terminology of special and general relativity, and presented his theory formally. Then, at the end of 1916, he published a small book on the special and entitled On the Special and the General Theory of Relativity, Generally Comprehensible. This work was written with as little mathematics as possible and was designed to appeal to an even broader readership, albeit one still somewhat educated in mathematics and physics. After arriving at the final form of his theory of general relativity in November 1915, Einstein proposed 3 possible tests for his theory. These involved the orbit of the planet Mercury, the bending of starlight near the Sun, and the redshift of light. Though all of these tests were successfully executed to confirm Einstein's theory. It was the second test that garnered the most attention and catapulted Einstein into international prominence. On November 6, 1919, a team of British astronomers led by Arthur Eddington reported to the Royal Society of London that during a recent total eclipse of the Sun, they had observed that the positions of the stars near the Sun appeared to have shifted slightly from their proper positions. The amount of bending was fully consistent with Einstein's theory of relativity. The publication of this finding in newspapers across the world made Einstein an immediate celebrity. The story was even more sensational considering that a German physicist's theory had been confirmed by a team of British astronomers just after World War I. Thus, all of Einstein's numerous contributions to physics, it was general relativity that won him the widespread fame and recognition he would enjoy for the rest of his life. In November 1922, when Einstein and Elsa were visiting Japan as part of an extended tour of the Far East, they received the news that Einstein had been awarded the 1921 Nobel Peace Prize in Physics. Although Einstein was most famous for his theory of relativity, the prize was officially awarded for his work on quantum theory. Next in his life throughout the 20s, it seems that he does loads of work on quantum theory, and then obviously throughout the 30s we've got some key events. So January 1933, the Nazis seized power in Germany. In March 1933, Einstein resigns from the Prussian Academy of Sciences and declares that he will not return to Germany. In October 17th, 1933, Einstein moves to the US with his wife and his secretary Helen Dukas. In December that year, Elsa Einstein dies in Princeton. In August 1939, Einstein signs a letter to Franklin D. Roosevelt, the president, urging the acceleration of atomic bomb development. Interesting. And then in October 1940, Einstein becomes an American citizen. Albert Einstein died of a ruptured aneurysm in a New Jersey hospital on April 18th, 1955. Although he is best remembered for his extraordinary contributions to modern physics, Einstein's life and thought left an impact not only on science but also on philosophy, visual art and literature. Of all his works, his theory of relativity had perhaps the farthest reaching implications for thinkers in all fields. Einstein helped transform the image of the scientist from a highly specialized student of nature to a public personality, deeply concerned about the fate of humanity. And there we have it. That concludes this very detailed look into the life of Albert Einstein. I've been sat here for a long time, so I'll obviously have to see how this turns out in post. I really hope it was still relaxing and informative, despite me making jokes about being lost with the science. In hindsight, it was probably a little bit science heavy, but if you're into that stuff, great. If you're not, might have bored you to sleep. But like I said, it's good to cover a variety of people. Now, on that note, please do leave comments for who you'd like to see covered in the next episode of Fascinating Figures. Obviously, we'll do another history. There'll be some conspiracies coming out soon. So yeah, all good stuff. So on that note, if you are new, do feel free to subscribe. My hand is absolutely dead, so I'm going to call the video there, everybody. Please leave a like if you did enjoy, everyone, and subscribe if you're new.